Hello everyone, this is Orhan Erdem. In this video, I'm going to show you how to solve basic time value of money problems in Excel using financial built-in functions. You can find the link to the Excel I'm using below the video. Let's start with the very first question. What's the simple interest on $100 at 10% per annum for 6 months? Okay, as you may remember from your book, as this is the interest formula. So interest is equal to present value times the interest I and times the n. N is the number of periods. Okay, so it only asks us to calculate the interest. So let's form a table here, which gives us the present value as $100, interest as 10%, and as 0.5. So how to calculate the interest? You need to use the formula again, right? Equal sign. What you need to do is to multiply all of these numbers. Present value, which is $100, interest rate $10%, and n is 6 months, which is half a year, but 0.5. That's why I use 0.5 here. What you need to do is just like this cell, okay, C8 times this cell, this is C9 times C10. When you hit the enter button, you have the answers. Boom, $5. Okay, this is just the interest. So it didn't ask us the future value, meaning like it didn't ask us how much is he going to have in total. If it was the case, we had to calculate. We have to write here our initial principal plus the interest. So he will have $1,005, but this was not the question, so I just delete those. So here is the second question. Raymond Gomez borrows $1,000 for 9 months at a rate of 8% per annum. How much will he have to pay at the end of 9-month period? Okay, so this was the question. Okay, again I formed the table here, so which is giving us the present value, interest rates, and number of periods. So I write here $1,000 as the present rate. Interest rate is 8%. So you have to write those numbers in a different cell than the question. So in order to use in calculating the answer. Okay, just click on any cell. What you need to do is to write equal sign present value times interest rate times number of periods. Here you have the interest rate. But the question is asking us how much will he have to repay at the end of 9 months, so he have to pay the principal back. So you add an equal sign here, which is present value plus the interest rate. So this is the borrowed amount plus the interest. So you have the answer here. Okay. So here is the answer. And here is the formula that you are using. Okay, we are using. So in order to follow the details. Now let's switch to the third question in order to practice more. So there's a guy, Bradley. He has deposited $8,000 in an investment account with a promised rate of 6% compounded annually. Okay, so this is an annual compounding. He plans to leave it there for 4 years. How much money will he be able to make at the end of the 4th year? Okay. What you need to do is to calculate the present, the future value. Using this formula, so this is a compounding question. So this money, present value plus the interest rate, should be earning interest rate in 4 years. So it's not just the principal, it's principal plus the interest rate. So this is the formula from our book. What you need to do is to write this formula. So present value, which is $8,000, be 32, okay, times, open a parenthesis, 1, just right here, 1 plus the interest, here is the interest rate, to the power, this is to the power sign, 4. Okay, just when you click the enter, you will have the answer. Excuse me. So I'm just trying to save it. So as you may remember, compound interest is the interest that's not paid only on the principal, but also on the interest rate earned, but not withdrawn during earlier periods. In this example, Bradley has deposited $8,000, and he is earning interest not on the principal, but also on the interest that it earned. Okay, so it's going to be compound interest. So this is a application of compound interest. So you can do this in this way by writing your own formula. Or, second way, you can use built-in functions. The built-in function is FV. Okay, when you just click on FV, you can understand what it does. So it returns the future value of an investment based on periodic constant payments and constant interest rates. Okay, FV, open a parenthesis. So the first thing it asks you is the rate. Okay, so here is the rate, 6%, B33. Then, comma, number of periods. How many periods we have? We have 4 years. Okay. What's the present value? No, it's the payment. We are not paying anything at all in between, so just write here 0. Okay. And what's the present value? The third item here is the present value. What's the present value? Just comma $8,000. When you click here, you'll have the answer. Boom. Okay. It's minus because you have to. Okay, you are giving this minus, so that's why it had to minus. So I'm correcting. So here it is. So you have to use minus sign here because you are paying that money in the beginning. So as you can see, the answers are the same. So this is a formula that we have written. Okay, this is the built-in function FV. So FV function is a function that we are using in calculating the future value. Now let's switch the second future value application sheet. Okay, here we have the questions, different questions. The first question is, what would the future value of $500 be after 5 years of 10% compound interest rate? So if it says compound interest rate, we have to use the compound function. So we have the FV function here. The answer is this, but instead of using the answer, we can use our own formula right here. FV, open the parentheses, what's the rate? The rate is 10%. What's the number of periods? 5 years. What is the payment? So we didn't make any payment, so you can choose 0 from here. What's the future value? Present value, it's $500. Click on parentheses, close the parentheses. You have the answer. I again did the same mistake, so this has to be minus just because you pay that money. Okay, we have the answer here. Second question is, how about 10% simple interest rate? If it was simple interest rate, what you need to do is to calculate annual interest rate once and multiply by 5. So annual interest rate, and you click here, you can see that you multiply the principal by the interest. So this is principal. Okay, C16 times the interest rate. So you have the $50 here, annual interest rate. Since this interest rate does not earn any interest on itself, you need to multiply it by 5. You have like $250, and you have to add this $250 to the principal. So okay, you have like 500 plus 250. Now let's switch to the second question. Suppose you currently have $3,000 and plan to purchase a 3-year certificate of deposit that pays 2% interest compounded annually. How much will you have when the CD matures? Okay, so it asks us to calculate the future value of $3,000 compound annually with 2% interest rate. What you need to do is just click any cell, use the built-in function FV, the future value of something. So the rate is 2%, number of periods is, so the rate is the interest rate, ampere is the number of periods, which is 3, okay? Excuse me, we have to use commas. The rate is 2%, comma, number of periods, and comma, payments, we don't make any payments in between, and the present value is $3,000. Okay, here you are. Again, I forgot this minus sign. Okay, Here you are. Okay, now the third question. Suppose a US government bond promises to pay 3,000 3 years from now. If the going interest rate on 3,000 3-year government bonds is 4%, how much is the bond worth today? Okay. So what you need to do, again, click here. This time we are going to use the present value function. The present value function is used equal sign. Write PV instead of FV. And you write here, it gives you the explanation. PV returns the present value of an investment, the total amount that has a series of future payments is worth now. Okay, so use the parentheses here. And the first thing it asks you is the rate, the 4%. Number of periods, how many number of periods we have? We have 3 periods, 3 years. And what's the third thing is payment again, so we don't make any, or US government bond does not make any payment in between, which is 0. And then the future value. The future value is $3,000 and it's here. Okay. When you hit the enter button, you have the answer. Okay. Again, same problem. Okay, it's worth 2,666. Part B is a little bit different than Part A. So how would your answer change if the bond matured in 5 years rather than 3 years? So what you need to do is just instead of 3 and we have N5 here. So what you need to do is just use equal sign, write present value, first just the interest rate here, and then comma, number of periods 5 this time, and we have 0 payments, we don't make any payments, so you can use 0 from here, and then this time use minus sign, and the future value is the same. Okay, here is the answer. So if the bond mature in 5 years rather than 3 years, the present value would be a little bit cheaper than that. So what if the interest rate on 5-year bond was 6% rather than 4%? So again, the same exercise. Use equal sign. This time we change the interest rate from 4% to 6%. Okay. So present value rate is 6%. Number of period is 5. We make no payments in between, which is 0. And then minus future value. Here's the answer. Now question 4A and 4B. Let's delete the answers from here. Okay. Okay, how much would $1 million due in 100 years be worth today if the discount rate was 3%? So what you need to do is right here, present value, rate is 3% this time, number of periods is 100 years, there's no payment in between, 0, and the future value is $1 million. Okay, hit the enter button, you have the answer. Again, I forgot minus sign here. Okay, here's the answer. So how would our answer change if the discount rate was 20%? Okay, just you can use again the same formula. This time change the answer to 20%. So it will be present value, rate is 10%, number of periods is 100, payment 0, future value is $100,000. Of course, the minus sign here. Okay, it's worth $0, as you can see. If the interest rate increases from 3% to 20%, it would be worth $0, almost 0.